Hi guys, we are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science. And today we are here with you to continue on chemistry, that is thermochemistry. In our last two lectures, we look at the theory governing thermochemistry. We were able to say that thermochemistry is the study of the heat or energy changes that is associated with chemical reactions. We're able to classify all the thermochemical reactions and explain them. In our second lecture, we look at the calorimetry, that is the practical way by which this energy change is determined. We gave you the formula connecting the specific heat capacity to the heat that is either absorbed or lost in a reaction. Today we are going to take questions to be able to use those equations to understand those theories. So let's take our first question. It says that when 0.18 grams of hexane underwent combustion, that is burning hexane in what? In excess oxygen, it raised the temperature of 100 grams water from 22 to 47. Calculate the heat change. So here we heated hexane, an organic compound hexane, and the heat rose a certain mass of water. From 22 to 47. And so calculate the heat change. So that is the meaning. The heat that came out in burning the hexane rose this from this to that. So here this means that we can practicalize the question. Okay, so we can simply demonstrate the question by doing this. Okay, so you can have a beaker, water inside, that will contain almost about 100 grams, okay, water. 100 grams of water will be inside, and you can burn them with this a lantern that contains the hexane. So this will contain the hexane inside. And so you can put it in a closed system. Okay, you can put this one in a closed system, and it says that when 0.8 gram hexane, that is the fuel inside the lantern, okay, when the 0.8 grams was used up, the temperature that rose from 22 degrees, the temperature of the water was initially 22 degrees Celsius, and when after the burn, the final temperature became 47, and they are now asking us to find the heat that is changed in the reaction. So here you can see that during the burning, the heat, okay, that came out from the burning was used to heat up this water. Assuming there's no heat loss in the surrounding, the same quantity of heat, okay, was used to raise 100 grams of water through a temperature through this temperature 22 to 47. And what is the quantity of heat that was used to heat the water from 22 to 47? So that is the meaning of the question. Okay, so we are going to find a way of solving it. And how do we do it? We have to write the solution and write the what? Have to write the solution. Okay, here what do we know? We know that the mass of the water, the mass of water that was heated up is equal to 100 grams. And again, we also learned that the mass of hexane that was burned as a fuel inside the lantern is 0.18 grams. 0.18 grams. And the temperature of water, the initial temperature of water was 22, and after heating it rose to what? To 47. So you can see that here the heat given out or lost by the heat lost by the hexane, okay, or emitted by the hexane is proportional to the heat absorbed by the water to raise this temperature from here to here. So it means that the heat lost by hexane during the burning, the heat lost by the hexane during the burning is proportional to the what? The heat proportional to the heat gain by the water. Okay, proportional to the heat gain by the water. It's proportional to the heat gain by water. And I showed you that the heat, okay, loss or gain is calculated by using the heat gain or loss is calculated by using the mass of the mass of the medium, by using the specific capacity of the medium times the mass of the medium, or times what? The change in temperature. And so since the heat loss okay, by the hexane, since the heat loss by the hexane, okay, is equal to the heat gained by the water. Let me just write H of the water. The heat gained by the water. Then it means that the heat gained by the water, okay, by mathematics can be found by using the specific heat capacity of the water, just as it is here, times the mass of the water, which was given to us in the question, times the change in temperature of the water. Have you gotten that? Times the change in temperature of the water. So we are just going to insert. We are simply going to insert, okay, and then we'll get the answer. So quickly, the heat, okay, gained by the water is going to be, the parameters are, the specific capacity of the water is this. Since we know the specific capacity of the water to be 4.18, so we are going to get 4.18. That is the specific capacity of water. That is kilojoule per kilogram per Kelvin. Okay, kilojoule per kilogram per Kelvin times the mass of the water. What is the mass of the water? Yeah, the mass of the water given to us was what? 100 grams, which is the same as what? Which is the same as 0.1 kilogram. Okay, now 1 kilogram. Now times the temperature change in the water. Yeah, the temperature change in the water. The temperature change in the water. So you subtract the 47 from you subtract the what? The 22 from the 47. And what are you going to get? You are going to get 25. Okay, we are going to get 25. So you are going to get 25 degrees Celsius. Now the difference is also the same as 25 Kelvin. 25 Kelvin, which is also the same as 25 Kelvin, because here if you add 273, okay, if you want to change, if you change each of the temperatures, this and this to what, to Kelvin, before you subtract, you still get the same 25 Celsius and Kelvin. So times the change in temperature, that is 22 from what, from 47. So we are going to get times 25, okay, times 25 what, Kelvin. So when you multiply your final answer, you know, this k will cancel this k. Have you gotten that? This will cancel this one. Okay, so finally we'll be left with only what, kilogram. That is, we'll be left with what, kilojoules. And the heat, okay, now will be given in, and the heat now will be given in this one. The heat gained by the water will be equal to what is 10.45. Again, what is 10.45? Okay, that is kilojoules. So actually, this is the question. This is actually the question. So this question is very simple. What it actually means is that you have to first understand the question. It says that when this mass of hexane underwent combustion, that is burning in what, in oxygen, it raised a certain mass of water, 100 grams, from 22 to 47. Calculate the heat change, and they gave the specific capacity of the water. So what you just have to do is to see and understand. When you say combustion, what do you understand by combustion? Burning a fuel in, or burning something in air. So there is air outside, and this burning is taking place. This burn is taking place. So the heat, okay, coming out from the fuel is used to heat up this mass of water, raising it from 22 to what, to 47. If this reaction is taking place under constant temperature and pressure, that is, if this reaction, okay, heat is not lost anywhere but directly going into the water, then it means that the heat liberated or lost by the hexane during the burning is the same as the heat gained by the what, by the water, because the water will be what, will take up and boil. And when that happens, you can say that if you want to find the heat change in a reaction, the heat given out by the hexane is proportional to the heat gained by the water. And in so doing, because we know the specific capacity of the water, every kilogram mass of water is supposed to take up 4.1. And so if you know the total kilogram of water that was used, which is what, 0.1, as the question says it here, 0.1, and then the change in what, in temperature, and the change in temperature here, okay, so the change in temperature here with the specific capacity, you just have to multiply. So you multiply all the figures, and then you realize that this is the heat that was absorbed by the what, by the water, and this heat is also proportional to the heat what, given out by the what, by the hexane. If we assume that there was no heat loss, heat didn't pass anywhere but went into the water. So that is the first question. That is the first question. We'll end the lecture here, and in our next episode we will solve the second question. We will solve the second question. Thank you.
My level up.
It's back.
Maybe today I don't get nothing, but tomorrow I go get something. And I go buy motor for mama. But the enemy won't worry me.